Okay, so good afternoon, class. Today we are going to solve some more problems. Okay, so in the last class also I have solved around 4 problems based on the phase relations. Okay, so time and again I'm stressing on this point that you should be very thorough with all the basic definitions and also derivations, also the formulas. Okay, all the phase relation formulas you should be very thorough. Then only you can able to solve these problems. Okay. So let me start today's problem. Okay, so what they are telling, a partially saturated sample from a borrow pit has a natural moisture content. Okay, so there is a borrow pit here. Okay, so let me draw a borrow pit. So borrow pit means it's there is a pit. We will dig some pit. Okay, so we'll take up the soil from there. Okay, so and we will take that soil sample and build some buildings or some for some construction activity we will use it. Okay, so that's what borrow pit means. Okay, so this is the borrow pit. Okay, so this is the ground level. Okay, from this we will take out the soil and we'll dig the soil and we'll take out and we'll place it wherever it is required for the construction, maybe for the construction of roads or some construction of some embankments. Okay, so here the borrow pit properties they given. What is the water content here? So water content will be 15%. Okay, and the bulk unit weight. So that is rho B. Okay, so it should not be bulk unit weight, it should be bulk density. Okay, so this should be density. So because why I am telling it should be density, because you see the unit here, they given in terms of gram per cc. Okay, so if at all if they are using unit weight, then unit should be in terms of kilonewton per meter cube. Okay, so since they have used a gram per cc, then it must be bulk density. Okay, so what should be the bulk density? What is the bulk density they given? They given around 1.9 gram per cc. Okay, the specific gravity also they given. What is the specific gravity of the soil sample? 2.70. So what they are asking, determine the degree of saturation, that is S they are asking. Okay, degree of saturation and White's ratio, E also they are asking. And also what will be the unit weight of a sample on saturation. That okay, so unit weight, again you see unit weight they are asking. Okay, so that means gamma sat. Okay, suppose if they want to ask the density, then that is the rho sat. Okay, so rho sat and gamma sat. Okay, always keep in mind the difference between rho and gamma. So this is the density. Okay, and this is the unit weight. So what is the unit of a density? It may be gram per cc or ton per meter cube or kg per meter cube. Okay, what is the unit of a unit weight? So it will be in terms of kilonewton per meter cube or meganewton or giganewton per meter cube. Okay, so like that we will get in the unit weight. Okay, so always keep in mind that the difference between density and unit weight. So density is nothing but mass per unit volume, unit weight is nothing but weight per unit volume. Okay, okay, so let me start here. uh, so let me, okay, so they given bulk density, they given. Okay, water content they given. Okay, so what I can find out, I can find out the dry density, right? So So yeah, or I can start like this. Okay, so what they ask? They ask a degree of saturation. Okay, so what is degree of saturation? S equal to I have two formula to calculate the degree of saturation, right? One is the volume of water by volume of whites, or I have one more formula, that is SC equal to W into GS. Okay, so water content I know, specific gravity I know, okay, but I don't know the whites ratio, right? Whites ratio I don't know, then I cannot use this formula. Okay, so then what are the things I know? I know the bulk density I know, and water content I know. Okay, so then I can find out the dry density. Okay, so what is the dry density? Gamma D equal to, or sorry, yeah, rho D. So rho D equal to dry density equal to bulk density divided by 1 plus water content. So what is the bulk density they given? 1.9 gram per cc. So 1.9 gram per cc divided by 1 plus, what is the water content? 0.15. 0.15. Okay, so you should get a dry density 1.65 gram per cc. Okay, okay, now I know the dry density. Okay, so but still I cannot find out S unless I know the E value. Okay, so from the dry density, what are the formula I have? So I have gamma D equal to GS into gamma W divided by 1 plus E. Okay, so here GS I know, anyway, density of water also I know. Okay, so let me write this as a density of water instead of in terms of unit weight. Okay, so that is rho W. So GS into rho W into divided by 1 plus E. Okay, so only unknown is E, I can find out. Okay, so 1 plus, so this equal to 1 plus E equal to, what is GS? GS is 2.7 into rho W. Rho W is what? 1 gram per cc. 1 gram per cc divided by your dry unit weight, dry density. How much I got? 1.65. Okay, so 1.65 gram per cc. Okay, so this gram per cc will go. Okay, so this equal to E equal to how much you will get? This much minus 1. Okay, so how much you will get? So 2.7 into 1 divided by 1.65. So how much you will get? 2.7 divided by 1.65 will be around 1.63. Okay, so 1.6, sorry, 1.63 minus this water plus 1 is the, no, here it should come on the right side. Okay, so this is 1. So now your E should be equal to 0.63. Okay, so your E value is 0.63. Okay, so this is first parameter I got. Okay, so E I got. Okay, so here this one I got. Now you put this E value. Okay, you put this E value in this formula, then I can find out the degree of saturation. Okay, so mm, let me get some more space here. Okay, okay, so second parameter I should know, I should calculate is degree of saturation. So what is the formula I have? I have the formula SE. This is the second parameter. So this is the first parameter I got. So SC equal to W into GS. Okay, so S equal to, what is the water content? 0.15 into, what is the specific gravity? 2.7 divided by, sorry, so divided by your whites ratio is 0.63. 0.63. So you should get a degree of saturation as around 0.63. 0.64. So that means around 64.4%. Okay. So there is one more parameter they are asking, that is the saturated unit weight. Okay. So they are asking saturated unit weight. So how I can find out the saturated unit weight? So this is the third parameter, asking gamma sat. So I know the formula, gamma sat equal to GS plus E divided by 1 plus E into, so let me write this one properly, 1 plus E into gamma W. Okay. So substitute here, specific gravity 2.7 plus E. E is how much? E just now we found out 0.63. 0.63 divided by 1 plus 0.63 into unit weight of water. Unit weight of water is 10. Okay. So or I can take 9.81 also I can take. Okay. So either you take 9.81 or 10. Okay. There will not be much difference in the answer. Okay. So for the sake of easy calculation, I will use the unit weight of water as a 10. Okay. Or you can use even 9.81 also. So calculate how much you will get. So you should get around 20.4 kilonewton per meter cube. Okay. So since they are asking unit weight, okay, so unit weight they are asking, no, that's why I'm using the unit weight of water. Okay. Suppose if they are asking density, saturated density. Okay. So suppose they are asking same problem, only in the same problem, instead of unit weight, so this is the saturated unit weight. Okay. So let me write here, saturated unit weight. Suppose they are asking saturated density. Saturated density. What should be the difference here? So I should write rho sat. So let me erase rho sat. So then what will change in the formula here? Here the only change, okay, so only change is here, instead of rho W, so sorry, instead of this rho W, I should write the density of water, that should be equal to around 1 gram per cc. Okay. So let me write here properly, gamma sat equal to GS plus E divided by 1 plus E, okay, into density of water. Okay. Okay. So same only here, 2.7 plus 0.63 divided by 1 plus 0.63. Okay. So the difference here, now the difference comes here is rho W. Okay. So rho W I can take 1 gram per cc. Okay. So 1 gram per cc. Okay. Now I will get 2.04 gram per cc. Okay. Gram per centimeter cube. Okay. So this is the sorry, this is the rho sat. This is the rho sat. Okay, that is the saturated density. Saturated density. So this is saturated unit weight. Okay, so you should what is the takeaway point here? You should be very thorough with the what do you mean by saturated density and what do you mean by saturated unit weight, saturated unit weight and saturated density. Okay, the difference is only here. Hmm? So if you are using a if you are calculating unit weight of water, sorry, unit saturated unit weight, then you should take unit weight of water. Suppose if you are calculating saturated density, then you should take density of water. Hmm? Okay. So coming to the next problem. So this is the second problem. So again, sorry, sixth. This is the sixth problem and today's second problem. Okay, so read it properly. So the what they are telling, the undisturbed soil at a borrow pit has a water content. Again, there is some borrow pit is here. Okay, so some borrow pit is there. So this is the borrow pit. Okay, so the undisturbed soil at a borrow pit has the water content. What is the water content here? W equal to water content is 15%. Voids ratio is 0.6 and specific gravity. Okay, so gs 2.70. Okay, the soil from the borrow pit is to be used for the construction of an embankment with a finished volume of 40,000 cubic meter. Okay, so what they are doing, they are constructing some embankment here. Okay, so this is the embankment. Okay, embankment. So what they are doing, they are taking off the soil from certain borrow pit and they have been constructing some embankment at some other place. Okay, so what is the total volume of the constructed embankment? Total volume is 4,000, or sorry, not 40,000 cubic meter. 40,000 cubic meter. Hmm? The specification for the embankment require a water content of 18%. Okay, so here, so whatever soil they will take out now. So first, what they will do, they will mix with some water, and then they will start putting layer by layer, and they will compact it, and like that they will build the embankment. Okay, so while doing that process, now their water content, whatever water content they should achieve at the embankment should be 18%. Okay, so the water content at the embankment is 18%. And the dry unit weight, dry unit weight is 1.76 gram per cc. Okay, so again you see same mistake they have done here. See, these problems are I have taken from the some textbooks only. Okay, so whatever they written I have taken out. Okay, so they should not use a unit weight here, because they here they given the density unit. Sorry, yeah. Okay, so what the mistake is given here in the problem? You see, they are given actually the density gram per cc, but you see they are using a unit weight. That should not be the case. If they are using density, then they must use dry density. Okay, not unit weight. Okay, so this should not be used. Okay, so this should be dry density. Hmm? Not unit weight. If suppose if they are using if they are really using unit weight, then it should be in terms of kilonewton per meter cube, not gram per cc. Okay, so since they are using gram per cc, then it must be density, not the unit weight. Hmm? Anyway, so this is the water content 18% and the dry density. Okay, so that is rho d. Huh? Rho d. Rho d is how much? rho d, that is the dry density, 1.76 gram per cc. Calculate the quantity of soil required to be excavated from the borrow pit. Okay, so what they are asking, calculate the quantity of soil required to be excavated from the borrow pit for the construction of an embankment. Okay, so they are asking here how much volume they have to remove to make this much volume. Okay, so that is 40,000 cubic meter embankment. To build this 40,000 cubic meter embankment, how much volume of soil they should remove from the borrow pit? That's what they are asking. Okay, so here calculate the quantity of soil required to be excavated from the borrow pit for the construction of an embankment. Okay, so what is the total volume? Sorry, so this is the volume of soil in the borrow pit, that's what they are asking. Calculate the quantity of soil required to be excavated from the borrow pit for the construction of an embankment. What would be its weight? Okay, so weight also they are asking. What is the weight of the embankment soil? Okay, so here they are asking weight of the embankment soil. Okay, so weight in the borrow pit and weight in the embankment soil embankment also they are asking. Okay, so how we can proceed? Think for a while, then we'll start the problem. Okay, one thing you should observe here. Okay, so whatever, something will be common. Okay, something will be common in the borrow pit and in the embankment. What is that common thing? Okay, what is the common thing? The common thing is the weight of solids. Okay, so weight of solids will not change here. Okay, the only what is changing here, water content they are changing, and also maybe some volume of whites will change. Okay, so volume of whites will change and water content will change, but one thing doesn't change. What is that? That is the weight of solid. Okay, so let me write that in red mark here. Okay, so weight of solids will be same. Weight of solids will be same in borrow pit, and embankment. Okay, so this weight of solids is not going to change. Okay, whether it is in a borrow pit or it is in a embankment. Okay, so that is weight of solids. Okay, so whether I can find out the weight of solids from these parameters or these parameters, just to think of. Okay, so I know the dry density, I know here. Okay, so what is the dry density actually? Huh? So dry density equal to what? Mass of solids. Okay, mass of solids divided by the total volume. Okay, I know the total volume, I know the dry density, I can find out the mass of solids. Okay, so mass of solids equal to dry density, how much? 1.76 gram per cc. Okay, into volume. What is the volume? 40,000 cubic meter. Okay, so this is in terms of cubic meter, this is in terms of centimeter cube. Okay, so that you should convert here, right? So uh, okay, so how I can convert? See, this whatever one relation is, you should remember. Okay, so 1 gram per cc is equal to 1 ton per meter cube. Okay, so this you should keep in mind. So 1.76 gram per cc is equivalent to 1.76 ton per meter cube. Okay, so now this is 1.76 ton per meter cube. Okay, into, so see, a dry density, I know this. If you go volume, what is the volume here? Volume is 40,000 cubic meter. 40,000 cubic meter. Okay, so the anyway cubic meter will get cancelled. Okay, you will get a mass of solids in terms of tons. Okay, so mass of solids equal to how much? So 1.76 into 40,000. Okay, so you will get around 70,400 ton. Okay, so this much is the mass of solids. So this you should remember. Okay, I know the mass of solids now. So what I can do here? So I told here mass of solids will be same in the borrow pit and in the this embankment. Okay, so both will be same here also. What is the mass of solids in the borrow pit here? Mass of solids in the borrow pit same only. Okay, 70,400 tons. Okay, so mass of solids I know. Okay, so I know the water content, specific gravity I know. Whether what I can find out, you see, whether I can find out the dry density in the borrow pit. Okay, so dry density in the embankment anyway they given. Okay, but they're not given the dry density in the embankment. That I can find out. Okay, so dry density in the borrow pit. Okay, borrow, I will write it borrow pit. Okay, so what is the dry density? Dry density is remember the what is the formula? Gs into density of water divided by 1 plus E. So what is the specific gravity they given? Specific gravity is 2.7. 2.7 into density of water, that is 1 ton per meter cube. Okay, so 1 gram per cc equal to 1 ton per meter cube. So rho W equal to 1 gram per cc equal to 1 ton per meter cube. Okay, so this is 1 ton per meter cube divided by 1 plus, what is the White's ratio they given? They given 0.6. 0.6. Okay, so what is the dry density in the borrow pit? Sorry. So rho D in the borrow pit. Rho D in the borrow pit. Okay, so how much you will get? Calculate 2.7 into 1 divided by 1 plus. Okay, so this will be around 1.687. 1.687. It may be in terms of gram per cc or ton per meter cube. Okay, because both are same only. One, say here 1 gram per cc is nothing but 1 ton per meter cube. Okay, so this is the dry density of the soil in the borrow pit. Okay, still we have not got our answer. Okay, our requirement is to find out the volume of the borrow pit. Okay, so how I can find out the volume of the borrow pit? So I know the dry density, I know the mass of solids in the borrow pit, then I can find out the volume. Okay, so what is the dry density formula? Dry density is equal to mass of solids mass of solids divided by total volume. Hmm? So I want to find out the volume, right? I want to find out the volume. So how I can find out volume? Okay. So I want to find out the volume of the soil to be removed from the borrow pit. Okay. Equal to mass of solids. Mass of solids is how much? 70,400 ton. 70,400 ton divided by volume. Volume. Volume only I want. Okay, so once you take the volume on the left hand side, then dry density will come in the new denominator. Okay, so just now we found out dry density as 1.687. Okay, so 1.687 ton per meter cube. Okay, so this ton will get cancelled. So whatever answer you will get, that will be in terms of meter cube. Okay, so this will go in the numerator, so it will come in terms of cubic meter. Okay, so how much cubic meter you will get? So substitute in the your calculator and calculate. So you will get around 4173 41730. Okay, so this much, this is your answer. 41730. So that is your first answer. Okay, so among this one, calculate the quantity of soil required to be excavated from the borrow pit. Okay, so how much quantity of volume you should excavate? 4170 41,730 cubic meter of soil you should remove. Okay, then only if you remove this much soil from the borrow pit, 41,730 cubic meter, if you remove this much soil, then you can able to construct a embankment of a 40,000 cubic meter embankment. Okay, so this much soil should be removed. So once this is the volume. Okay, so what should be the mass? How much weight of the soil should be removed? This is the volume of soil to be removed. Okay, so your second part of the question is that. Okay, so that means they are asking what should be the weight. Okay, weight also they are asking, weight of soil from the borrow pit. So the mass of soil that has to be taken out from the borrow pit, the mass of soil that has to be taken out from the borrow pit. So how I can find out that one? So I know one formula. Okay, what is that? Mass of solids equal to total mass divided by 1 plus W. If with this I can, okay, so I want total mass, right? So total mass is equal to mass of solids, I know 70,400 ton. 70,400 ton into 1 plus W. 1 plus what is the water content in that borrow pit? Borrow pit water content is 15%. Okay, so 0.15. So 0.15. So total mass is equal to, so calculate how much, 70,400 into 1 plus 1.15. So you will get around 80,960. Sorry, 80,960 tons. Okay, this is the mass of soil to be taken from borrow pit. Okay, So there is a one more quantity they are asking. Okay, so this is my second answer, answer of the second part of the question. Okay, so this is, okay, so this is also an answer. Okay, so there is a third part in the problem. What is that third part? You see, go to that problem. What is the third part? What is the weight of the embankment soil? Okay, so they are asking weight of the embankment soil. Okay, this you can, same concept you can follow. I know the water content, huh? I know the mass of solids, and obviously I can find out the weight, total weight. Okay, so mass of soil in embankment. Okay, so that equal to mass is equal to, so mass of solids in the embankment into water content in the embankment. So mass of solids in the embankment, anyway it is not going to change. Mass of solids is not going to change in the embankment or in the borrow pit. Okay, so same 70,400 tons into 1 plus the water content. Okay, so in the borrow pit the water content is 15%. Okay, but in the embankment the water content is 18%. Okay, so 0.18. So if you calculate this one, you will get 83,000 83,072 tons. Tons. Hmm? So keep in mind this is in embankment. This is in borrow pit. Okay. So this is also, this is the third part of your question. Okay, so you observe here. Okay, so the weight of the soil removed from the borrow pit is 80,960, right? The weight of the soil in the embankment is 83,000. Okay, what is the difference here? You see the difference between your 80,960 minus 83,072. Okay, so around 2,112 tons is the difference of the weight between your the embankment and sorry, your borrow pit and embankment. Okay, so this whatever 2,112 tons is there, no? So this 2,112 ton, from where it is coming? From water. Why water? Because you see the water content earlier it was just 15%. Okay, but while building the embankment the water content is 18%. Okay, so whatever difference in weight is there now, whatever difference in the total weight of your borrow pit and total weight of your embankment is coming from your increased water content in the embankment. Okay, so that's why here the weight is more here. Okay, because you are mixing more water here. Okay, 18% of the 18% you are mixing, but naturally the water content was around 15%. Okay, so around how much? 3% water you are increasing here. Okay, so that is showing in your increase in the total weight of the embankment. Okay, I hope this problem will be clear for you. Okay, so kindly go through slowly, you go through everything. Okay, so if at all if you have any doubts, okay, so you can ask me in the live sessions. Okay, so coming to the next problem, that is the seventh problem. Okay, so okay, so see what they are telling in the this problem. So the undisturbed soil at borrow pit has bulk unit weight. So let me check whether it's recording. Yeah, recording. recording. Okay. Yeah. So read the problem. The undisturbed soil at a borrow pit has bulk unit weight. Again, borrow pit is here. Okay, so there is a borrow pit. So let me take the pen with light, thinner one. Okay. So undisturbed soil sample. The undisturbed soil at a borrow pit has bulk unit weight. Okay, so they are telling what is the bulk unit weight? 19. Okay, so again there is a borrow pit here. So let me draw a small borrow pit here. So this is what borrow pit. Okay. So what is the bulk unit weight? Gamma bulk. Gamma bulk is 19.1 kilo Newton per meter cube. And the water content. Okay, so what is the water content? 9.5%. Okay, 9.5%. The soil from this borrow pit will be used to construct a compacted fill with a finished volume of 42,000 cubic meter. Okay, so again here also they are removing the soil and they are building some embankment. Okay, so let me draw the embankment here. Okay, so this may be some road embankment or some railway embankment or some other dam. Okay, so depend. So it depends which what is the structure. Okay, so the soil from this borrow pit will be used to construct a compacted fill with a finished volume. Okay, so what is the total volume? Finished volume, total volume. This is the impact embankment. Okay, so what is the total volume? Finished total volume is 42,000 cubic meter. Okay, the soil is excavated by machinery and placed in trucks, each with a capacity of 4.5 cubic meter. Okay, so this soil has been transported to the embankment site through a truck. Okay, so let me draw a small truck here. So suppose this is the truck. huh? So these are the wheels of a truck. Okay, so this is the truck. Okay, so what they are doing, they are removing the soil from the borrow pit and putting in the truck, and they have been transporting to the embankment site. Hmm? So the soil excavated by machinery placed in truck, each with a capacity of 4.5 cubic meter. Okay, what is the volume of soil placed in the truck is equal to 4.5 cubic meter. Hmm? When loaded to the full capacity, each load of soil weighs 67.5 kilometer. Okay, so what is the weight? Weight of soil 67.5 kilo Newton. In the construction process, the truck dumps the soil at the site. Okay, so this will take the soil to the, and it will dump it here. Soil. Then soil is spread and broken. Okay, so that's what they will do. Once you will put the soil, and they will because some boulders will be there here. Okay, so they will break it to small part. Okay, so they will break down and they will mix with some water. Okay, so water is then sprinkled to bring the water content to 15%. Okay, so now the water content at the embankment is how much? 15%. Hmm? Finally, the soil is compacted to dry unit weight of 17.1 kilonewton. Okay, so what is the dry unit weight? 17.1 kilonewton per meter cube. Okay, so for this density, they have to compact the soil. Okay, so they are asking three parameters. What is that one? First, assuming each load is to the full capacity. Okay, so assume that the truck is carrying all the loads at its full capacity. Okay, so how many truck loads are required to construct that full? Okay, so number of truck loads they want. They want to find out how many number of truck loads are required to construct this much of volume. Okay. This is the first question. And second question is what should be the volume of the pit in the borrow area? Okay, so it's volume they are asking. Okay, so volume of pit. So volume of pit they are asking. And how many liters of water should be added? Okay, so see, from 9.5% of water content they increased to 15%. Okay, so for that purpose how many number of how many liters of water should be added to a truckload? Okay, suppose one truckload is dumped here. Okay, so how much liters of water should be added to that soil before placing in the embankment? That is the third uh, question mark. Okay, yeah, again the same funda you should use here. Okay, so what is that same funda? So in the previous problem I shown you the in the previous problem. What is that? So weight of solids will be same in borrow pit and embankment. Okay, so here and here the weight of solids will not change. Okay, so what is going to change? Only weight of water is changing. Okay, but the weight of solids is remaining same. Anyway, weight of air is zero. So in the total weight, so only weight of water is changing. So the same funda you should use here. Okay, so let me copy this one entire thing. I think I can copy here. Okay, so anyway, let me write it here one more time. There is no issue at all. So important note here. Okay, so what is that important note? The weight of solids, that is W S is same or will remain same. I can write, or will be same, will be same in embankment embankment and borrow pit. Okay, so now whether I can calculate something from here, whatever parameters they given dry density they given, and what they given, yeah, volume they given. Yeah, I can find out this one, total volume I can find out, right? So what is dry density here? Dry density is nothing but, okay, so in the embankment. Okay, so let me take in embankment in, okay, so what is dry density? Dry density, sorry, dry unit weight I should call, not density, because of gamma it is, dry unit weight equal to weight of solids, hmm, divided by total volume. Hmm. So what is the dry density? Sorry, dry unit weight 17.1 kilonewton per meter cube. 17.1 kilonewton per meter cube into volume. Volume is how much? 42,000 cubic meter. 42,000 cubic meter will be my weight of solids. Hmm? So my weight of solids. See, sometimes I will write WS or sometimes I will write full solid. Huh? Weight of solids. This is nothing but Ws hmm, equal to what? 17.1. This cubic meter will go cancel. So I will get in terms of kilonewton. I will get the answer in terms of kilonewton. So I will get how much? 17.1 into 42,000. So you should get around 71,000 or 7 lakh 18,200 kilonewton. 7 lakh 18,200 kilonewton. So this much. This is the weight of solids. Okay. So same weight of solids also will be present in the pit also. uh, in the borrow pit also the same weight of solids will be there. See this sentence you see. Okay. Okay, then so okay, so one more thing will be common between borrow pit and your truck. What is that? Huh? Some So you see the water content is not going to change, right? Except if you neglect that whatever from the top portion, if at all, if it is very far away. Okay, so in the due course of time, little bit some amount of water may loss at the topmost layer of soil in the truck, but unless okay, so if you neglect that, the water content will be same in the borrow pit as well as in the truck load. I am not going to add any water here. Okay, in between the transportation uh, phenomena. Okay, so water content water content in truck and borrow pit will be same. Okay, so bracket you can write neglecting loss of water content due to evaporation. Okay, so why I'm writing this one? Just to make sure that whatever is little bit of water content is will get evaporated from the top layer, that you can neglect it will be very very less. Hmm? So except that if you assume that, then water content will be same in the borrow pit as well as in your tractor. Hmm? So let me get some space here. Actually, I need a very large space because it's a very big problem. Okay. Yeah. So then start. Okay. So what is the water content here? You see the total weight they given. Hmm? So water content. So find out the water content. So what is water content actually? W equal to weight of water by weight of solids, right? So water content in the pit, you see, in the pit 9.5%. Okay, so 0.95 equal to. So what is the weight of water? Weight of water is nothing but total weight minus weight of solids in the borrow pit. I'm talking. Okay, so divided by weight of solids, right? So I already calculated weight of solids, right, in the embankment. Okay, so that will be same in even in the borrow pit also, right? So so that I can find out the total weight of soil in the borrow pit. Okay, so 0.95 equal to total weight minus weight of solids. How much? Weight of solids is 71,000. 71,000. Okay, so let me check. Some mistake is here. Okay, so here whatever water content I am finding out now. So this water content I am finding out in the truck. Okay, not in the borrow pit. Okay, so this is not in the borrow pit. Okay, this is in the truck. Since whatever water content is present in the truck and borrow pit will be same. Okay, that's why I am using 0.95 whatever water content is given here. Okay, so this 9.5% is there. Yeah, 0.095 should write. This is not 0.95. So yeah, let me erase this one and then start from the beginning. Okay, okay. So you see, up to here it is clear, I hope. Okay, so what with blue letter I have written water content in a truck and borrow pit will be same. Okay, so why it is same? Because I am not going to add any water. Only little bit of water will be lost due to some evaporation. Okay, so if you neglect that, then water content in the borrow pit and your truck will be same. Okay, so if you utilize that funda here, so I can find out what is the water content in the truck. So it is same as the water content in the borrow pit. Okay, that is 9.5%. Okay, so 9.5% means in decimal you should, if you keep 0.095 equal to, so weight of water in the truck. So weight of water in the truck is nothing but total weight minus weight of solids divided by weight of solids. Okay, so yeah, so weight of solids in truck, weight of solids in truck, huh? This all in truck only, huh? This everything in truck, weight of solids in truck equal to, so total weight they given. Okay, total weight how much they given? It can carry 67.5 kilonewton of the soil. So 67.5 kilonewton minus weight of solids in the truck, I don't know, right? Weight of solids, uh, weight of solids in the truck, did I know weight of solids? Okay, so what is that here? This is the weight of solids in the truck divided by weight of solids in the truck. So if you simplify this one, 67.5 divided by weight of solids minus weight of solids by weight of solids. Okay, so nothing is going to change in the your previous equation. Okay, so this will get cancelled, it will become 1. If it go this side, it will become plus 1. Okay, so here your water content in the truck is 0.095. Okay, so one point, if it minus, if it comes on the left side, it will become plus 1. Plus 1 plus 0.095 equal to 1.095 equal to 67.5 divided by weight of solids. Hmm. So I want weight of solids, right, in the truck. So weight of solids in truck equal to 67.5 divided by 1.095. So which should be equal to 61.64 kilo Newton. Okay. So this is your weight of solids in the truck. Okay. So now let me get the some space here. Okay, now you know the weight of truck, weight of solids in the truck. Okay, so now you can calculate the number, first quantity. Okay, what is the first quantity? Number of truck truck number of truck loads required. number of truck loads required. Okay, so what is the total solids required? Total solids required divided by the solids carried by one trip of the truck will give you number of truckloads. Okay, ws ws sorry ws total divided by w weight of solids in truck will give you loads, how many loads are required. So total weight of solids, total weight of solids, how much we have calculated? 71,000, 7 lakh 18,200 kilonewton. 7 lakh 18,200 kilonewton. Okay, so each truck, how much solids it can carry? It can carry only 61.64 kilonewton. 61.64 kilonewton. Okay, so if you divide it, then you will get a number of trucks. So number of truck loads equal to, so divide it, how much you will get? See, so you should get around 11,651.53. Okay, so since these are the number of trips, then it should be some whole number. So 11,652, these many trips it should make. Okay, so that means 11,652 times, 11,652 times it should carry to build this much big embankment. Hmm? If at all only one truck is going, no, then how many times it should go? It should go 11,652 times. Okay, next, what is the next quantity they are asking? What should be the volume of pit in the borrow area they are asking? That means the volume of borrow area. So second quantity they are asking, volume of pit or borrow area. Hmm? At borrow pit, what are the quantities you know? At borrow pit, I know the water content. Okay, so I know the water content. I know. Huh? What is the water content at the borrow pit? 9.5%. Okay, so equal to 9.5%. And also I know the weight of solids. Huh? Weight of solids I know. How much? So whatever weight of solids is there in the embankment, no, the same weight of solids also will be present in the borrow pit. Okay, so this sentence you read, then you will appreciate why I am taking same weight of solids in even in the borrow pit also. 71,000, so sorry, 7 lakh 18,200 kilonewton. 7 lakh 7 lakh 18,200 kilonewton is the weight of solids in the borrow pit. Okay, now what is the water content? Water content is nothing but weight of water by weight of solids. Okay, so water content, I don't know only weight of water. Okay, so this is the question mark. So to find out the weight of water, so water content into weight of solids. So what is the water content? 0.095% into weight of solids is 7 lakh 18,000. 7 lakh 18,200 kilonewton. Okay, so weight of water should be 68,000 kilonewton. If you calculate this, 68,200 229 kilonewton. Okay. So then what is the total weight? Total weight of soil from borrow pit is equal to total weight is nothing but weight of solids plus weight of water. So weight of solids is 7,18,200, 7,18,200 kilonewton plus weight of water is 68,000, 68,229, sorry, 68,220, 68,220, 68,000, 68,229, 68,229 kilonewton. Okay, so this should be equal to 78,000, sorry, 7 lakh 86,000, 7 lakh 86,000 429, 429 kilo Newton is the total weight of soil to be removed from the borrow pit. Okay, now so this is the weight. Okay, so they are asking volume, right? They are now I got the weight, they are asking volume. Okay, so how I can find out the volume? If I know the bulk unit weight, then I can find the volume. There they given bulk unit weight. Yes, bulk unit weight they given in the borrow pit. Hmm? So what is the bulk unit weight formula? Gamma b equal to total weight by total volume, right? So bulk unit weight, how much they given in the borrow pit? Huh? How much? 19.1 kilonewton. Hmm? So right here, so I want volume, right? So your volume equal to your weight divided by bulk. Bulk is how much? Bulk, yeah, total weight is this much, 7 lakh 86,429 kilo Newton. Okay, and your bulk unit weight is how much? 19.1 kilo Newton per meter cube. Okay, so this kilonewton get cancelled. Whatever answer you get is in terms of meter cube. So your answer will be 41,174.3. Okay, this much cubic meter of volume of soil is removed from the borrow pit. So volume from borrow pit. Hmm? So this much volume has to be removed from the borrow pit. Okay, how much it is? 4 lakh, sorry, 41,174, yeah, 41,174.3 cubic meter of the soil has to be removed. Then only you can build how much volume? With the 42,000 cubic meter. Okay, okay, so there is a third part. What is the third part? Third part is how many liters of water should be added to a truckload. Okay, so whenever a truck will bring the soil from the borrow pit, they will add some water. Okay, because they have to increase the water content to 15%. Okay, so in the borrow pit it was 9.5%. Now the water content has to be uh, increased, right? So yeah, so my third part of the question. So let me write here. Third part. How many liters per trip? How many liters of water had to be added per trip is the question mark. Okay. So weight of solids per truckload we calculate, right? Weight of solids per truckload. Weight of solids per truckload. Okay, how much we calculated weight of solids per truckload? Yeah, weight of solids per truckload is 61.64 kilonewton. Hmm? So 61.64 kilonewton. And water content is increased from, and water content is increased from how much? In the borrow pit, how much it was? In the borrow pit, it was 9.5%. Okay. In the embankment, it is 15%. How much it has been increased? Increased from 9.5 to from 9.5% to 15%. Okay. So the quantity of water has to be added per truckload. So quantity of water has to be added per truckload. Okay, how I can calculate? So what is the water content especially? After all, water content is nothing but weight of water by weight of solids. Okay, so I want to find out weight of water. Okay, so weight of water is equal to weight of solids. I know in the truck how much? 61.64. 61.64. Okay, 61.64 into the water content. Water content how much? From 9.5, 15 minus 9.5. Huh? So that is the difference. That much of water you should add. 9.5 it was in the borrow pit, and 15% it should be increased to 15% in the embankment. Okay, so the difference is around 5.5%. Okay, so 5.5% difference. That means if you want to put it in decimal, then it is 0.055. So that equal to 3.39 kilo Newton. Okay, so this much weight of water has to be added. Okay, so this much weight of water has to be added per trip. Okay, so whenever one trip of soil come to the field, so you should weigh 3.39 kilonewton of the water, mix that water, and then construct your embankment. Okay, but usually we won't weigh the water in kilonewton. No, we will measure the water in terms of some liters, right? Okay, so let me put it in terms of liters. So to do that, so what is the density unit weight of water? Unit weight of water is equal to weight of water by, sorry, so weight of water by volume of water. Okay, so I know the weight of water, I know. Unit weight of water also I know. I want to find out the volume of water. Okay, so volume of water is equal to, so weight of water by unit weight of water. So what is the weight of water? 3.39 kilo Newton divided by unit weight of water. Huh? So unit weight of water is 9.81 kilo Newton per meter cube. Okay, so kilonewton will get cancelled, and whatever answer you will get, that will be in terms of meter cube. Hmm? So 3.39 divided by 9.81 will give you 0.345. 0.345 cubic meter of the soil. Okay. So this much cubic meter of soil. Okay. So now if you want to convert this into liters, no? So 1 cubic meter of soil, 1 cubic meter of water is equal to 1000 liters. 1000 liters. So 0.345 cubic meter is equal to how much liter? Okay, 0.345 into 1000 divided by 1. Okay, so you have to add 345 liters of water per truckload, per truck. Hmm? So 345 liters of water you have to add per truck. Okay. So what should be the total water? Total water is nothing but 345, and how many number of truckloads you will carry? You will carry around something. Yeah, these many 11,652. Okay, 11,652 multiplied by 345 liters will give you the total amount of water to be added in the construction of your embankment. Okay, so anyway, that is not asked in the question, so simply I just to further this problem I told that. Okay, so here itself it's the end. Okay, so they ask only how many liters of water should be added to the truckload. Okay, suppose if you want to find out one more, if I want to add D here. So how much? What is the total liters of water to be added there for the construction of the embankment? Okay, if I ask that one, then number of truckloads multiplied by number of liters of water added per truckload will give you the total amount of water to be used in the construction of your embankment. Hmm? So this is very practical problem. You see, very interesting problem it is. Even though it is a very lengthy problem, you may not expect, don't expect this kind of problem, very big problem in your VTU exam. Okay, so that I solved this problem just to appreciate how these phase relations will be used in your field problem. Okay, just to correlate that field actual problem, I took up this problem. Okay, so this is very lengthy problem. So in the VTU examination, they may ask one or two quantity from this. Okay, but concept is same. Okay, so the concept is very important here. Hmm? So don't worry about the length of the problem. Hmm? So once you are very thorough with the procedure, no, this problem can be solved within a 4 to 5 minutes. Hmm? Okay. So what I suggest you, just go through these all the problems, and then if at all if you have any problems, you can ask in the coming live sessions. Okay, so I will take up 8, 9, 10. Okay, some few more problems are there. Okay, those I will take up in the next lecture. Okay, so let me stop here, and please go through these problems whatever till now I have solved. Okay, so if at all if you have any doubts, ask me in the coming classes. Okay.